Hey everybody, I'm really excited to tell you about a new project that I'm working on. I've been thinking about it for a long time. Actually, back in January, I mentioned that I had plans to do this year to my members, and they thought I think that was crazy. So anyway, I love trying to do this stuff, and it's not so much of worrying about failure. It's trying to learn something from it, even no matter what the outcome is. But this is going really good, and I am feeling really confident. So I want to introduce you to HarmoniCAF. It's my harmonic drive, strain wheel drive project, total DIY. I'm going to run you through the design work and prototyping and show you where I'm at with it for right now. So anyway, my name is Doug. This is AstroAF, and stick around, check out HarmoniCAF. All right, so a couple things I want to take care of in this video is to show you the design files, which will come up here next, and we'll run through all the design drawings that I have for each of the parts, which are actually laid out in front of me here just off camera, and we're going to have a look at those here in just a little bit. We'll go through an assembly, and I'll show you how all this comes together. So the purpose of this is prototyping, and I am building what will eventually be a functional prototype. At this point, it's going to be a non-functional prototype. We're testing the fit of all of the components together and clearances, and making sure that we don't have any interferences, things like that. And from there, going to progress into electronics and programming and testing here in the prototype until it's a functional prototype. And once all of that is done, then I want to have this prototype body and the whole assembly machined out of aluminum to create the final product. But not until I'm confident in everything that I'm doing here. But I'm feeling really good about stuff. It's going really well, and I'm really happy with the way that this is coming together. So anyway, we'll have a look at the design files. We'll run through that, and then we'll do an assembly. And once we get that done, we'll come back, and I'll talk to you more about next steps. All right, down here in Fusion, we will just do a quick run through of all the parts that are involved. You can see my parts basically library over here for the entire project, along with drawings and things like that. And we'll do a quick run through of these, starting with I was able to get some manufacturer's drawings of like the stepper motors here. So these are that's the deck that was up, and this is the RA drives that, or not drives, but stepper motors that I'm using in the project. And that was just out of convenience, and these are to help me understand the geometric spatial relationships within the mount enclosure, the mount body, so that I can make sure that I am laying things out correctly. We start with the base plate, which is the very bottom. There is one part that's below this, but this is the plate that everything mounts to, and we'll go through all these parts here as we come up. And so this is several different parts. So this is basically the body assembly and what we can see here. And so we've got the drives, which are here, and the motors, and this is the deck on this side. And on the bottom here, we've got, this is called the alt triangle. So this is the altitude triangle and a pivot pin, and these are individual parts that are part of an assembly here. And there's another drive that's on the bottom with, for the RA and its own motor, and we'll see that here in just a second. I think I can kind of hide that, and then you can see that we've got this other drive here, the harmonic reducer. These reducers are 100-to-1 ratio drives, and so for every rotation of the stepper motors around in 360 degrees, that's going to be a 100-to-1 ratio as it transfers out through the drive. It will have a very fine control. I think this is going to be a really good setup for both torque and for very fine control of both the RA and the deck axes. If we then go over to we can look at the drives here real quick. So this is another manufacturer's drawing, and it basically just shows the drive. This is completely parametric and can be, every single part is in here. It's actually kind of nice, but I didn't need to take it apart as far as that's concerned here within the design drawing. But this gives you an idea of the drive itself. On this side, this is where the drive shaft inserts into and then spins here on. This would be like the spline, the flex spline here, and this would be like the strain wave generator bearing here. Just a little bit of an eccentric bearing that causes the cool effect of the rotation that actually spins this kind of basket that's here, which is the strain wave gears. So anyway, really cool. I learned a lot about strain wave in this process, which is just really neat. In some cases, it was actually trying to wrap my head around some things and the way that they work was challenging, but it was really cool to get into. If we keep moving on, we can see basically the assembly of one of the stepper motors and the drive. We are missing a flange, an adapter that mounts from the back of the drive flange to the motor mount. And this plane that I have here that I'm highlighting is actually the distance from that plane to here is the dimension of the thickness of that adapter. And I didn't need that adapter in the designs because really it was just extra work, and it's provided with the drive, so it wasn't a part that I had to make. So anyway, I just allowed for it in this gap that's between here and here. And then getting into parts, this one here real quick, it's just a gasket. I'm going to print this out of TPU and use it since it's a custom size to fit. This is going to, for the body, it's going to be a seal. What I call the north end plate is to the north pointing position of the mount body. And then also on the RA end plate that we'll see here in a minute, I want to have a weatherproof seal that runs around that. So that's going to get printed. And then I have this EQ alt adjustment block, and this is basically a stopping block. This limits how far the mount can rotate in altitude, and I'll show you again here coming up. Just take these parts as kind of individual right now. We'll look at them in their context here shortly. And I have another one here, and this is the alt adjust. It's just like the other one, except this one here has got the alt adjustment bolt threads in it, and this is going to be how we adjust the altitude. And these are the yokes or EQ alt triangles, and these 3 holes on each one of these, they mount down to that base that we saw first. So, and then these come up, and there's a pin that runs through these yokes here, and that's our main pivot point for altitude adjustment. And then as far as that, this is the pin that runs through the middle of those yokes from end to end. And then we have, this is another bit of an assembly here. So we've got a few parts, but this is an adapter hub here. And if I get rid of that triangle, we can see some more on how this comes together. So that triangle, if you see, so we've got that pin, and I've got a couple thrust washers, and this is an interesting spherical bearing here. And the inside of this bearing will actually rotate within its journal 360 degrees. And the reason I'm going to use this here is I'm going to have one alt adjustment bolt instead of one on either side. And this will be a push-pull. And inside here in this inner diameter, I'm going to actually put a threaded insert, and it will be permanently affixed on the inside of that. And then when this rotates across, so if we put that triangle back, this is in that triangle, this rotates back and forth and sweeps. And so the alt adjustment bolt comes in here, and that angle is going to change as this rotation changes. And the reason I wanted to have that spherical bearing is to accommodate that change of angle as it sweeps back and forth. It's kind of a cool design, and it took me a while to figure that out. This will actually go from 30 degrees to 90 degrees of altitude, and I'm really happy about that. And anyway, this spherical bearing will allow me to do that with a single bolt that does both push-pull. If we look at this hub, this is the way that this mounts to the drive. So there's 6 holes on the drive, and if we actually go back and look at that just briefly, we can see that if I go around to the other side, maybe, here, we've got 6 threaded bolt holes that receive that. So on the hub, this hub will bolt directly to that. And then this will mount here to another part of the assembly, which if we just go over here to this, so that mounts to these holes here on this alt triangle. The interesting thing is this doesn't spin. And if we go back and look at this motor spins here. But what happens is this is actually stationary, and it is the whole body that spins around this, and this is fixed. And that was kind of a thing there. I was like trying to wrap my head around for a little bit to understand how the strain wave. So in effect, when I configure the drive controller, it will be reversed so that we are taking into consideration that that this hub is actually fixed and the entire body is rotating around it in the RA axis. So anyway, it's really cool. And then I've got the deck axis here. It does the same thing. It's a little bit taller here because I'm accommodating some bolts here that are going to be for mounting the Losmandy clamp onto this, which is what I'm going to mount the Losmandy rail that my telescope is connected to. Those 2 M8 bolts, so I made this adapter here thicker so that I could accommodate a longer thread in here for strength. This is the entire alt base assembly. And so on the bottom here, which is this other part that we can look at real quick. So this is just it's a locating block, and this fits down inside the recess of like the tripod and is threaded to accept the 3/8 bolt that comes up through the bottom of a tripod. Like for Skywatcher, I'm designing around that because I have a Skywatcher tripod, and I also have a Skywatcher type of adapter that is going to go on my pier. And so anyway, I just decided to standardize on that 3/8 here, so it works for both my tripod and on my pier. Going back over here to the base assembly, we can see that is mounted to the base plate here. And if we go look at the other sides, then we've got these yokes, which are basically the EQ alt triangles. And we've got these 2 alt blocks here that limit the travel. And I've got this mounting block here that we hadn't seen yet. And it's this part. And this part basically is reinforcement. It is threaded to accept that 3/8 thread from the Skywatcher bolt. And then it has 3 holes on either side of it for the yokes, for additional support for the yokes, because this is the main support bearing, of the entire altitude adjustment and support is in these yokes. So this base plate here supports these, allows these to be bolted through into it, as well as the yokes are bolted through to the bottom. And anyway, that gives a really firm, stiff support for the entire assembly going upward from here. If we go into the mount body now, we saw this earlier in the assembly, but this is just by itself. So we've got this is the deck pass through, with the pass through holes here to mount the drive assembly to it. And we've got this is actually going to be a 6-inch square aluminum tube with a 1/4-inch wall, and it has, remember that little gasket that I showed you? Well, there's a groove all the way around here that gasket's going to sit into, and then the end plate, which we can look at, comes in, and it has a recess here that's cut into it. So this slides down, and it is really close tolerances. It's not press fit, but it's very close tolerances, and this is to assist with resistance against torque. And then it just bolts down into the top, in this case, which is the north end plate. So it slides down inside here. It seals with the gasket, and then it bolts down to secure it. And with the tight tolerances, that'll help us prevent any torque, which I doubt we'll have anyway with a solid aluminum 1/4-inch square tubing. It's not going to go anywhere. And then on the RA side, and in this, I've created my control panel. So now we're looking at it from the bottom, but this is the orientation that it will be in space, when it's sitting on the mount. So this is going to be a pass-through for a power button, and this is a USB-C pass-through, and this is a power 12-volt DC that's going to come in here to power the mount. And then again, we've got the drive pass-through here with the mounting bolts that come through it. Then if we look a little bit further, we've got, here's that spherical bearing that we saw earlier, and this was also just a manufacturer supplied part. I have a T-bolt, or actually a T-nut here, and that goes into the body side. This is actually a counterweight, where I'd screw a counterweight bar into, and I can show you that here when we get to the full assembly. And then we also had the thrust washers. So there's just a couple of these. So that's pretty much all the parts. So we can go over to the full assembly now and see the whole thing at once. Let me update that and get rid of that warning. Yeah, so what we've got is this alt base here. And again, we'll pull it up here a little bit and zoom in. So yeah, so we've got a travel of 30 to 90 degrees of altitude, and I can actually show you that, I think. Here, let's see if it's not too hard to do it. If I select the body assembly, and then we will move, and then say we want to rotate, and then I've got that selected, and our axis will just be this here. Then we can see that this altitude can adjust like this, and if we zoom in, then we can, this is our limiting of travel. Our push-pull bolt comes through here and into that spherical bearing. And so this is that sweep that I was telling you about. And then as we rotate, so we can get over here to 90, and that at that point right there, we'll start getting interference in that front block. So that's our positive stop. It won't go any further than that. And then going back the other direction, then that bolt would be turning, so the bolt would be the bolt doesn't actually move in and out. It will just it's just going to turn through this and pull this or push this spherical bearing. But if we can see that we can come over here, and I've got an indicator right there, so, and we can go a little bit further, and be on 30. So yeah, so anyway, that's how the altitude adjustment works, and how this all comes together. So we'll cancel out of that rotation, and so all of this comes together through this triangle, is controlled through this altitude bolt, which allows that rotation of the entire mount assembly, and then the mount spins around this hub. So this hub is stationary, but when the motor spins inside it turns the whole mount body. That's contrary to the way that the deck works. The deck actually, it spins this, and so the whole hub assembly spins, and it's not fixed. So it works exactly opposite of the way that the RA works. So anyway, let me show you a quick animation of the blow up of this, and then we can go ahead and start moving in and take a look at assembling the prototype. So yeah, so that was the culmination of the design and that process starting in on this. Oh, that had a little over 2 months in it of work, and not 8-hour days or anything. I was working on it little bits at a time during evenings and stuff like that, and weekends. But the thought process into this actually started about, last January. I actually brought it up to my members in my Discord channel, and maybe they thought I was a little bit crazy for thinking about trying this, but that's all the fun part of it, is to see and to learn, and even if it doesn't pan out, then at least have a fun time doing it and learn something. And actually, I learned a lot about harmonic drives in this process. I had no idea how they worked before getting into this and starting into the design and starting to think about how the RA and the deck rotation actually happen with a harmonic drive. So anyway, lots of cool stuff. And so again, as I mentioned, in front of me here, I've got the assembly. So we're going to jump into that, and I'll just go ahead and put this thing together for you and show you how it comes. But first, I'll kind of show you the parts here as they are in real, and that you just saw in the designs, and hopefully bring that together a little bit for you. Yeah, and then I'll go ahead and start putting all this together. All right, down here on the desk, so I've got all the parts laid out. I'm going to show you the body here first, and it's kind of tight where we're at, but basically it's cube. I'm going to be using 6-inch square aluminum tubing, and we have the drive pass-through here, and this is the deck drive pass-through. On the other side here, I've got that T-nut, which comes through and bolts on the inside, and that's threaded, and that's going to be for the counterbalance bar. And not much else to that. There's a recess in here, and there's also a groove where I'm going to print I think it's a PLU, I think, if that's right, a gasket. So I'll just print my gasket on my printer. And then we can see it here. I've got the RA end plate, which you can see has basically a rabbet that this recesses into that box and then seals with that gasket that I'll put in that groove there. And then it will screw down from the top and fit in there. And this is pretty tight tolerances. And this will also help for preventing any torsion, which I doubt with 1/4-inch aluminum square tubing it's going to have that problem at all, but this will help ensure that we definitely don't. And then we've got the RA drive, and this is also control panel. So I have the pass-through for the RA drive, and then I've got power and USB, and this is the power switch rather, and this is the input, the 12-volt input coming from the power supply. And I've got these are 100-to-1 ratio harmonic drives, and so these are really nice, and they really, I think there's create a lot of torque, but with the 100-to-1 ratio, they're going to be very refined, and so for every rotation of the drive motor, of the stepper motor, we'll have a 100-to-1 reduction. And I have 2 of those, one for the RA and one for the deck. Then, kind of starting with the base, we've got the sub base plate, and this is for basically ensuring that the whole drive mount, the mount assembly, slides into the tripod or the peer adapter, and this fits down inside like this, except it is a little bit closer tolerances. This makes sure that you're aligned and makes it easy to get the bolt aligned up the center of it. And then we've got basically the Alt-Az base plate, and this accepts the screws for the sub base plate, and it also has another plate that goes on top here, which is to add some additional support for not only for the bolt that comes up through the bottom, but also has screw holes on either side of it, which allow me to bolt these yokes into that on either side. So we'll segue here into the yokes. So each of these yokes is designed to support, here's those 3 holes that I was talking about. So those will go bolt into the side of that. And then the bottom, there's 3 more holes here that are threaded, and that sits into the base plate like so, and bolts down from the bottom. We've got an arc. This is an indicator just so we can see our angle. I think eventually I will have some degrees on here. I do have them in the plans. This is also drilled here for the altitude blocks that go in between the yokes, and again we'll see that. And then basically the altitude pivot pin, which is here, which slides in to the yoke, and these are all pretty tight tolerances, and that's what the entire top of the mount assembly rotates on. There's again that pin. I've got a couple of thrust washers that go on either side of that pin, which we'll see here shortly. These are the stop blocks for the altitude, and one of these has got an M8 thread through it, and it interfaces with this alt triangle. And in here, this is kind of cool. I didn't want to have a 2 knobs, one for push pull. I wanted to have one knob that did both push and pull, and so I put in this cool spherical bearing here, and this rotates 360 in here, so I can get as much angle as I can fit with the geometry. And that way, when this is rotating, the bolt that's running in here is going to change angle, and so this can basically move with the bolt as this is pivoting back and forth with the mount angle. And then inside here, I don't have it in yet, I'm going to press fit a threaded insert in here and probably set it in with JB Weld, and that's going to be an M8, and then the altitude adjustment bolt will run into there, and as I tighten the bolt, it'll pull it or push it if I'm loosening the bolt, and change the altitude. In addition, the pin here is threaded with M12 threads on either side, and when this comes together, this will be through here with the thrust bearings and washers, and then these yokes, and then I'll have a thumb screw or a knob with M12 on either side of this that sandwiches it all together and tightens things up on here. So that basically is a secondary locking mechanism so that this won't rotate in the yoke once I get my altitude set. And then I have these hubs, and this is the deck hub, and it has a 6-bolt pattern here that matches up to the drive. There's 6 holes here, and then I also have 2 M8 holes here in this hub, and that's going to be what my clamping plate for my Losman derail will bolt down into. And then I have the RA, which is similar. It has the 6-bolt pattern here, but then in order to be able to assemble this to here, this goes and mounts on top, and then this will bolt into that bolt pattern here to attach this hub to this triangle, and then this hub will be attached to the RA drive, and that's how this makes the connection to build the whole mount assembly together. And that's pretty much all of the parts. So let's go ahead and jump into assembly here, and we will just go ahead and see how this all comes together. right, so this is HarmoniCAF, and I hope you like this video. It was kind of fun to make, and I am having a really good time with this, and I'm really happy with the way everything is coming together. And you know, this base assembly, it's basically 0 or 30 degrees to 90 degrees of altitude range. So I'm really happy about that. And it's not, I haven't weighed this yet, and obviously this is the PTG, but it's not that heavy. The drives and once I get the motors in here, those are the heaviest components, I think. But once I get the aluminum, obviously the body's gonna start taking on some more weight. But I don't think it's gonna be overly heavy. I'm looking forward to weighing it and figuring out what it actually is. But yeah, so I'm excited about this, and I hope you're having fun and coming along on this little project journey with me. I love doing this kind of stuff. Next steps are getting into the electronics. I've got like all kinds of stuff here. I've got the entire electronics BOM. I've got PCBs. I've got the switches and everything for the control panel. I've got microprocessors here. So anyway, tons of stuff to do yet to even get to a point where this is a functional prototype. But right now we have an unfunctional prototype that I can, you know, obviously I can make sure that all the articulation and clearances and everything are all working the way that I need them to, and I think they are. I've got some my alt adjustment knob coming. I've got my azimuth adjustment knobs coming, and those lock screws for the altitude pen is coming. I don't have them yet. It should be about a week, and I'll get those, and then I can actually test the altitude bolt with that spherical bearing. That's mainly the last thing to really test for mechanical functional. And after that, we're just going to jump into electrical. So stay tuned for next videos. We'll be working on the electrical, these other little things that I was talking about here with the knobs and so forth, and then the microprocessor firmware, and actually doing some testing of the axes in the software. So going to be OnStep is what I'm using, and that's going to be fully ASCOM compliant. I've already got it compiled, and I already have all my configuration and everything. So for members, I will be making these files available to you, and that'll be available through a link on Discord. If you're interested in supporting my projects and my content creation, then I'd love to have you as a member. You can get members only section, early access to videos and other perks. And if not, you know, I have merch available if you want to pick up a t-shirt and like something to return. You know, obviously I have a merch store and would love your support in that way if you would like to. So, and otherwise, just your subscription and your thumbs up, maybe share with a friend if you think that they would like this video. So anyway, my name is Doug. This is AstroAF, and here, check out HarmoniCAF.